All right, let's dive right in. Today, we're pulling back the curtain on DevOps, the culture, the tools, the whole shebang that's really driving how modern software gets built. And our guide through all this is the fantastic second edition of Learning DevOps by clip³. So let's get into it.
You know, the book just puts it perfectly. If you're in tech, you feel this. There's this constant, relentless pressure on companies to ship new features, new products, and to do it faster than ever before. But, as you know, speed isn't everything.
And that leads to this classic tug of war, right? You can rush things out the door super fast, but if they're full of bugs, your users are going to be unhappy, and your teams, they're going to be stuck putting out fires 24/7. Or you can take your sweet time, build something rock solid and stable, but by the time you launch, you might be totally left in the dust by your competitors.
So what do? How do you get the best of both worlds? How can you move fast and not break things? Well, that is the exact problem that DevOps was born to solve. It's all about breaking down the walls, the fortresses that have traditionally kept all the different teams separate.
Okay, and this is so important to get right. DevOps isn't really a tool you can buy. It's a culture. It's a mindset shift. It's about getting everyone, your developers, your operations folks, the testers, the security experts, all in the same room, working together as one team right from the very start. And this whole culture really stands on three main pillars. Collaboration is the obvious one. Everyone has to be on the same page. Streamlined processes? That's just a fancy way of saying we need to automate all the repetitive, boring stuff. And the right tools? Well, those are the shared platforms that actually let everyone collaborate and make that automation possible. So how does this actually look in the real world? Well, it all starts with automating the journey that code takes from a developer's laptop all the way into the hands of a user. And you've probably heard the term for this, CI/CD. Continuous integration, or CI, is all about creating this incredibly fast feedback loop. So developers are constantly merging their code into one shared place. And every single time they do that, a whole automated process kicks off. It builds the code, and it runs a whole suite of tests against it. What this means is, if something breaks, you know about it almost instantly. It's like finding a tiny little crack in a building's foundation before it has a chance to become a major disaster. Now, pay attention to this, because this is the golden rule. The book is crystal clear on this point. It is so tempting when a test is failing to just, turn it off so the build goes green. But that is a massive mistake. Because that little bug you just ignored, it is almost guaranteed to come back and haunt you later in production, where fixing it is way more expensive and 100 times more stressful. Then we have continuous delivery, or CD, which takes that automation to the next level. So after your code passes all the builds and tests in CI, CD automatically pushes it out to different environments, like a staging area. The whole point here is to make sure your software is always in a state where it's ready to go live, literally at the push of a button. Okay, so we've got the code delivery on autopilot. That's great. But what about the actual servers, the databases, the networks that our code needs to run on? Well, that brings us to the next game-changing practice, infrastructure as code. And there are basically two ways to do this. The first is called imperative. It's like giving the system a detailed recipe. Do this, then do that, then do this next thing. The other way is declarative, which is what tools like Terraform use. Here, you don't give it a recipe, you just describe the final meal you want. You tell it what you want the end result to be, and the tool is smart enough to figure out how to get there. And this declarative way is usually what people prefer, because it prevents something called configuration drift. That's when small manual changes over time mess things up and make your servers inconsistent. Speaking of Terraform, it is an absolute giant in this space, and its whole workflow is designed around being predictable and safe. It all starts with the init command, which basically just gets your project directory ready to go. Next up, and this is maybe the most important step, is plan. Think of this as a dress rehearsal. It shows you exactly what's going to change in your cloud setup before you actually do anything. No surprises. Then, once you've looked at the plan and you're happy with it, it's showtime. You run apply, and Terraform goes and makes that plan a reality, building out all of your infrastructure for you. And finally, when you're done with that environment, maybe it was just for testing, you run destroy. It's the cleanup crew. It tears everything down cleanly so you don't get left with a bunch of random resources and a surprise bill at the end of the month. This whole cycle, init, plan, apply, destroy, is what makes it so powerful. Now, here's a little pop quiz. To keep track of everything it builds, Terraform uses a special file called a state file. It's basically Terraform's memory. So what do you think would happen if you're working with a team and that file accidentally gets deleted? Yeah, pretty much. Total chaos. If that file disappears, Terraform has amnesia.
It has no idea what it's already built. And this is exactly why best practice is to store that state file somewhere safe and remote, like in an Azure storage account. It protects the file, it lets your whole team work together, and it even locks the files so two people can't accidentally try to make conflicting changes at the same time. Okay, so Terraform is obviously a huge deal here, but it doesn't work in a vacuum, right? It's part of a whole team of tools that make the entire DevOps workflow possible. Let's take a quick look at the rest of the toolkit. You can see how these tools all have their own specific job. You've got Git for managing the code itself, then Terraform comes in and provisions the raw infrastructure, like your virtual machines. But those machines are just empty boxes, so you use a tool like Ansible to actually install and configure all the software on them. And to make things even faster, a tool called Packer can create pre-configured server images, so you're not starting from a blank slate every single time. Now, Git is the absolute foundation of all of this. What makes it distributed? Well, think of it this way. Every single developer has a full, complete copy of the project's entire history right on their own laptop. This is a massive leap from older systems. It means you can work from anywhere, even on a plane with no Wi-Fi, and it makes the whole system incredibly resilient. For a developer, the daily routine with Git becomes this simple little rhythm. You commit your changes, which is like saving your work locally, then you push your commits up to share them with the rest of the team, and you pull down the latest changes that everyone else has pushed. This commit, push, pull cycle is really the heartbeat of modern software collaboration. So we've talked about a lot of tools and a lot of processes, but let's zoom back out for a second. Because like we said at the very beginning, this is really about a fundamental change in how people think and how they work together. So what's the bottom line here? All these things, CI/CD, infrastructure as code, Git, they're not just trendy buzzwords. They're the real-world tools that bring the DevOps mindset to life. They are the mechanisms that let teams finally solve that speed versus stability dilemma, helping them ship better software, faster, and work together a whole lot better. And that really leaves us with one final question to think about. The question for you is, what's one small step you can take? How can you start bringing these core ideas, collaboration, automation, and quick feedback into your own work, whatever it is you do? It's definitely something worth thinking about. Thanks for tuning in.